Hello, everyone, and welcome to the broadcast. I'm newtmechanist, and today we are going to be continuing our game dev project. We're going to try to finish wiring up the new visual class structure. And ideally, that will let us get into the particle effect visuals. I think it's a good opportunity to do that. Again, if we get this visual structure in, it's going to make the explosions a little easier to incorporate. Let's check in with the kitties first, though. We do have Molly up in the cat tree. Sky is... I don't know what Sky's up to. He just darted over and is looking over the end of the desk intently. Mason is up in the tree. Ribbit is hiding in the footrest. And unclear where Ember is. Sammy is on the table next to where Sky has run over to. Ember may be looking out the window. Hard to say, but she would normally be visible otherwise. Or she would be getting a snack, and she is not. But yeah. Coding. Okie dokie. So last time we got these, the visual sprites set up. We are currently using those by default in the entity node renderer, where all visuals that come in are the entity visual sprite. And I see we have 2time over there on tall format. Let me make sure that this is functional. I'm just gonna give this app a restart because it didn't come through on the aggregation. So there may be a nuance in how the tall chat is rendered. Either way, we'll see. Getting all connected up. There we go. Okie dokie. But right now we're using that by default, and we load it up. Load. So all things are currently using the sprite visual. We've just hard overridden it. Accomplishes largely the same thing now. For those keeping track, gameplay-wise, we're still very much where we were. The heart system is one of the, quote, newer elements in the last week or so. Heart system allows us to have both your standard heart kind of concept. We could have half hearts rendered. We currently don't. Nothing I have set up does half hearts. But it's what drives the bouncing of the yarn balls as well. Let's clear some space. So those yarn balls that are bouncing because of bounce hearts. If we give them another bounce heart, then any given yarn ball bounces twice. If we give them a pierce effect, they gain a pierce heart. And which order we put it in is relevant, because it will go left to right. Hey there, sharpshooter. Welcome. So it will process left to right through this. So if it goes this way, the first heart they get is a bounce heart. So they're going to have a regular heart, a bounce heart, and then a pierce heart. That means when they take damage, the first one to get hit will be the pierce heart. What a pierce heart does is it eats the hit. In the background, it eats the hit. Yeah, Mason's getting his snooze on over there on the bed. We'll see if anybody joins them. I rearranged the blankets to see if we can get better visibility on all of them. I think the positioning's good. In the background, a pierce heart just eats the hit so that the that collision essentially doesn't register. If we were to do it this way, it would bounce, then pierce, then bounce again before it ran out of health, before the final hit runs out of health. So if we do a pierce first, the bullets will pass through the target. Well, it will seem like they hit and just don't go away. But then the subsequent 2 hits will bounce. If we swap the order, that would be bounce, pierce, bounce. We can see it better if we reduce the number of projectiles. But we'll give it a burst just so that we can... I mean, ultimately, potentially pretty hard to see. The blobs move too fast. From a practical perspective, if you had this kind of enemy in place, it wouldn't be a seeking enemy. Or you would need to have the expectation that the player could move faster. That is the kind of thing I do want to avoid. I'd rather have the player be able to outrun them than to have too many raw stat boosting upgrades. We will get to that kind of thing. A perk system, if you will. But the core system that we want to get in place are... the core system is going to be this. We want to spend more time on this before we move on to the next, functional system. Okay, but we left off getting entity visuals in place. So most of the system assumes that it's just an entity visual, and that's what we want. We will make them and we will update them. Now, we need to not cache them. And that's going to be part of the next one, is right now we say, oh, get a visual, and we look for it by ID. If we find one, then we load it up. If we don't find it, then we just use that one. If we don't find one, then we're going to make a new one. So right here, we pull the child off, but we leave it in. We leave it as something that exists within the collection. That's something that we're going to have to remove. We need to get rid of them. We're going to see what kind of impact that has. The reason we need to get rid of them is that there's now going to be different types. It's important that you get the right type. Well, the right class, but, it's still a type. Okay, so if it contains the key, we're going to get it. We're not going to change this for now. It should be viable. What we need to do... Okay, we get visual here. We're just going to make a visual here. We make it and we add it to the collection. So it's always going to be this. Just so. So we're not using get visual anymore. We use the identifier, though, to be able to get them. We don't actually need that. If we're going to remove them, we won't need an ID on a visual. Because again, the visual is entirely for finding them again. But since I'm just removing the ID here and removing the child, we don't need to do that. So we're gonna verify that this works, and verify if there's any sort of massive performance drain. Minor performance drain is okay, but we should be able to do this with no problem. Oh, that's a real hitch there. Look at that. That is a real hitch. Okay, we can't do that. All right, so we need to have these cached. We need to have their nodes cached. So one of the things that we could do would be to keep them by type. To cache them by type. We don't need... When we remove them, we just need to keep them. So we have a dictionary of types. And each of those is contains a dictionary of nodes. It'd really be like a queue of nodes. So what this would do is say, okay, if we get a type and we haven't seen it before, then we're going to create a new queue for that type. We load that into the dictionary, and then we load the corresponding node into the queue here. What that is that is the node of a visual. We should keep the entity visual. We should keep the whole visual. Yeah. So every time we make one, we are going to... We're going to create that queue, and that will be a queue of that type. It'll be a queue of entity visuals, but we're going to list it by the type. It could be a queue of the given type. Yeah, you get it. I wonder if we'll be able to do it specifically. Anyhow, so if we get a new entity entering, we're going to check what its visual is. We're going to get the type. Once we get that type, there's complexity here. What we want to do is we want to avoid creating new nodes if we can avoid it. So an entity visual has a node on it. This is a risk surface. Because that node represents a new Godot tree operation here. We have to allocate resources in order to make this thing. And every time we're doing that, if we watch, we are spending a lot of effort. So when it's just one thing, like a couple of things a second, not an issue. But we're going to ramp this up to like 28 things a second plus. Now we can see there's a noticeable hitch that happens every second. So tick, tick, tick kind of thing. And it's not showing up in the frames per second because it's fully hitching the application. If we push it way up, you can really see it. It's almost like a half-second beat happening each time. It's not affecting the rendering, but it's affecting the processing as the CPU kind of lurches. So we can't have that. And if we're recreating the sprites, that's going to be a similar issue. I don't think there's anything we can do about recreating the sprite, but the node we could save. So let's see if we can store those nodes off, and then we can set that node. Okay, so there's a decent chance we won't get to the particle effects today because we have a fundamental issue with the way that we're doing this. But ultimately, we were already doing a lot of this, and it wasn't hitching performance much. So as long as we keep these nodes around, as long as we keep the visuals around, I think we should be in okay shape. Which means we're still going to need IDs. We need to get the type, and then we're going to get the ID in order to find it within the corresponding collection. Yeah. So that we can find that one. We could do it as a hash set where each node is only present in that state, but I don't know if that'll play nice. Because we could do a hash set of the nodes so that we don't, of the visual objects, so that we don't have to have the ID to find them. So let's noodle this out here. So we have a dictionary, and that is of a type and of I wonder if we could do we'll just leave type there. And that will be of a hash set, which is of can I do type T? Is a hash set of visual entity visuals. Okay, so we've prepped it. It exists. Hash set. So again, what we're doing here is that we're creating, we're storing off any of these nodes that we create. No. Needs to be a dictionary. I'll explain this in just a moment. Entity. Visual. Hello, Ember. Hello, baby. It says sherbet's in my spot. Perhaps sometime this week I will go and retrieve some of the... see if I can get some of the infrastructure pieces that I would like to start moving some of the cameras, or at least start replacing some of the cameras. In particular, camera 1 here that we can see Sherbet on is very prone to freezing up. It will occasionally be that it's still showing the cat as if it's napping, but if you look close, the cat won't be moving because the camera is frozen. But we need... So, what we're looking at here is within the type, we still need an integer on the dictionary to be the identifier. We're using the identifiers right here, where we are creating this stack of integers here. Because what we want to do is say, okay, if this ID is available, we're going to use that ID again. Oh, that still won't work. Oh, man. Because that identifier will be specific to a list of available ones. Okay. We can still do this. So if it already exists, that's not a problem. Okay, okay. Okay, okay. Okay, what if it's a queue? So we have them by type, and then we have a queue of them. These are available ones. These aren't existing ones, they're available ones. That, get rid of you, and do queue. Doesn't actually have to be a queue, it could just be a list, but we want a push pop kind of behavior. Where we can easily add to and pull from the array. Yeah. Okay, and we're not going to need available IDs in this scenario. And in a similar fashion, we shouldn't need this anymore. We'll get to this in a moment. We're going to leave these as is for now. Okay, so when an entity is added, we're going to leave all the vestigial stuff at the moment. Actually, unfortunate quick break. I will be right back. And we're back. Sorry about that. Okay. So we're going to leave this kind of as is. But we do need a... So this is going to be different. Oh, man. What can we do for this? Okay, before we get too far into the weeds on that, what if... What if we were to save the node? Can we save the node? Let's revert our file here a moment. Save for our visual data here. Okay. Discard. Okay, make sure we're still functioning. Okay. So we're still caching them in this scenario. Again, we can't cache these the way that we're setting out to. There is going to be a type that lingers. If we... Hey, Drew. Hello. It's going to be a type... We need to keep the typing around for that visual. But we can reuse the visual. So once it's duplicated for the entity, when we get it, we don't have to worry about reusing it. That visual can stick around indefinitely. And we can leverage that. So the entity should have a visual key, not a visual itself. You could also have the typing in there, but that gets fiddly. Was hoping that we were going to get to particles, but we're probably not going to. We might get into the skeleton of them. Right now we have a texture key. We would need an entity visual in here. If it's just a visual key, that's fine, but it would necessitate us duplicating the actual visual. If doing... So every time we create one of these, we're creating a node. Every time we set the entity, we are removing the sprite. It's our remove sprite. Okay, we rip the sprite out every time we do this. So it's okay. It's the removal of the node. We want the node. So we could have a getter setter on node. We look here. So we have a node. If we assume that they have to be given the node, we could have initialize take a node and say this is the node you will use. So if we say node is equal to node, node 2D. Okay, this will break a couple of other things. So in our set entity, we're going to need to clean the node. And in our set entity, we are cleaning up the node. Okay. So at this point, we have a node. We can mess with stuff. Okay. Then in our node renderer, we just need an ID for the node. And if the visual object contains an ID, yeah. Okay. So the visual still contains an ID. That is its node identifier. Yeah. Does it need one? No, we don't need one. Okay. Bear with me. We can have this be a stack. Say stack of node 2D. Using Godot. So what we're going to do is we're going to check and see if there is a node in the node cache. If there isn't a node in the node cache, we're going to make one. And we're going to give it to that visual. Node. Count is greater than 0. To return. Hey, Tess. Unfortunate terminology in Godot for those that have who have Node.js trauma. Does this give us? No, let's not do that. We'll just pop one. Pop. Turn. Bracket. So when we've duplicated the entity, the entity doesn't need to have a visual, it needs to have a visual key. Otherwise, we're just going to be copying them anyway. And we don't want the entity to contain its visual. Okay. But for now, we are going to create one. Entity, visual, sprite. Not copying it, we're just making a new one. We're going to initialize with a node, which is going to be getNode. Okay, so we have our node. This is not being used anymore. That's good. On remove, we'll keep the ID in there for now. We'll fix that. Hey there, nope. Welcome. We're continuing the initial implementation of our new visual rendering in Godot here. It's a bit of nuance that we haven't got, but we're getting there. Push. Does this break it? Well, okay. 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 Not using view anymore. And ultimately, we're not really using the identifier anymore. This is good. This is good. Probably should have saved it before I did this. So I'm about to have to Control Z a whole lot if this breaks it. Okay. The fact that the explosion is not perpetually going off or having problems is a good sign. Spam a whole bunch of them. Really strain it. Okay, we don't have the visual hitch. It's the node. It's the initial node that it wasn't liking us messing with. Sprite, it doesn't seem to care as much. This is good. This is good. Okay, so because it doesn't care about us messing with a node, we don't need a stack of entity visuals. Again, we never use them. So we pull it free of the tree, we stuff it in the cache. Excellent. This is okay. So the next thing is the entity needs a visual key. So in the background, a bit of yesterday and some of today, I did this, which is make visual files that correspond to each one of the entity files. So in this case, player. And what this contains is a reference to the texture wrapper. It is a creation vector for the visual sprite. So by getting this key, we're going to be able to use that in here. Again, the entity just contains a reference to it. Hey, diminished, welcome. Bullet visuals, yes. And we need bullets. We are going to try... Okay, let's hang on. Well, thank you, Diminished. I appreciate it. Let's see. Don't believe they are present, but if Delusive Maki and Tanashiro Kiki are present, please give a wave to Diminish there to thank them for the gift subs. This guy is being adorable there. Yeah, I see you. Got a slow blink out of that. Okay. So if this is instead visual key, for visual, instead of being sprite bullet, that is contained in the actual. What did you use to make an AI there, Nope? Quotation marks in to indicate that it is actually a string value in the JSON. Okay. These are bullets. Go into our entity file, our enemy files. Visual for blob. Neuro is a pretty impressive piece of work. I mean, not having stuttery internet is good. I have had some internet issues recently. We did have a drop in Sunday stream, which was very irritating. And last couple of days, I've had a couple of drops in the internet. They've recovered, but very irritating. I had to perform the ritual of the cable modem reset recently. You know, light the incense and apply the sacred unguents. Unguents. Weird word. Visual key. Layer. I don't actually need to spread these apart, but it's very likely that most of the things in a given file will have similar visuals. Hey there, troll. Hello, Levi. Welcome, everyone. Welcome. Visual for the player. Go in, we'll put that right there, and we'll change this to a visual key. Okay, and the visual key is just a string. It is not a translatable one. So we just want that key. Then in our sprite, we aren't looking for... This is our copy, but this will already have been loaded. Oh, that's okay. That's okay. That's our copy, which will have been loaded from that. When we set the entity, that's when we're going to get... Right here, we're getting our texture key. But we aren't actually going to do any frame generation based on the entity. This is going to be during the load up. So during our actual initialize, during the actual setup of them. Let's check our flow here. Okay, this is when we get an entity and a node set. We can't generate our frames without... No, we can. We don't care about which entity. We just need to have a particular type. If I get a copy of the visual node from the entity, all I'm adding to it, when I set the entity, all I'm adding to it is something that can say when the entity goes away. Yeah, nope, this is our 131st day of, our 131st stream of doing this. I'm trying to accelerate it, but by doing more offline coding, but 3-hour streams do not make for drastic progress. But yeah, I'm trying to do more of these streams so we can see more progress. Okay, if the entity is just for getting the event, a 24-hour stream. I mean, if there's a big event, I'm not averse to a super long stream. 24 hours, though? I mean, there have been plenty of days where that kind of wakefulness is involuntary. Yes, 24 hours would be a killer stream in a variety of ways. My sleep schedule is easily disrupted. Currently, I'm off kilter by about 12 hours. And probably more like 7. It's not good, but it's not disrupting stream, so, you know. I mean, chatbots can be interesting. Just trying to think through this. As we tell it the node and entity, it needs to know that. There's nothing about the actual constructor that is fundamental to all of them. Okay, so this is us duplicating the content of the current visual when we copy them. So we're going to have protected void initialize sprite. We have this here. Can we do... Duplicate. Yes. It's equal to visual dot sprite dot duplicate. Animated sprite 2D. There's an echo, you say? Is there? Wouldn't think so. Anybody else getting that? Would like to verify. It would not be the first time that my audio messed up. We can do a quick verification. Just be sure, you know. I flipped the audio just in case, but okay. You may want to check nope. Sometimes either the browser itself, there's also the possibility that you've managed to get 2 of the windows open. I don't know how that would be, but it also depends on if you're... Yeah, usually that ends up happening because you have 2 active windows. How that might occur, not sure. I have the ability to relay my microphone back to my to relay my audio back to me from the streaming computer, but it throws me off. I cannot hear my voice and echo and continue to operate. Okay, so we duplicate the sprite. Okay. And then we don't rebuild the sprite. unless here. So when we initialize the sprite, we just need create sprite, actually. But we don't add the child yet. So for those that are arriving later or trying to catch up, we are refining the way that we're adding visuals to the system to avoid having a lot of Godot lag related to node 2Ds being created and destroyed. And instead, we're focusing on words and things. We are focusing on trying to get it so that this can actually be a dictionary object. That as soon as we create it, we can generate the sprite. Ideally, we would be able to, but we can't here. We cannot generate it here. Because we don't have a texture wrapper yet. And even if we have the texture wrapper, I'm not confident that we have enough information. Let's roll with that, though. We can do this. We can do this. Okay. So here, we're still going to set it that way. No, we don't want to do that. Can't do that because we don't want to remake the sprite here. So we're going to set the node and we set the entity here. We don't need to worry about whatever the entity is doing here. We're not going to create sprite here. We're going to remove the entity. Our generate frames does not happen here. Our generate frames happens in our initialize here. And that's only if the sprite does not exist. So that's if sprite is equal to null. We're going to create the initial sprite. We already have our texture wrapper. It's just default values there. We generate our frames. We are not relying on anything in the entity here. Set the node's position. So the assertion here is that we already have a node. And when we create the sprite, we add it to the node. But that's not really where we want to add it. It's really when we create sprite. All of this needs to happen when we create the sprite. Is all if sprite is null. We have made the sprite. And then we can say sprite node.addChild sprite. So as of here, node is set. We can use node. If we don't have a sprite yet, we generate it, and then we attach it. We need to do it here because by this time, like here, we know that we have the sprite because we have copied it. Well, we have copied it here. Oh, but it might not be ready. Let's find a kitty. Shelf. So the tricky part here is I'm trying to find the right time to generate the sprite. The sprite needs to have this. We don't want to duplicate the sprite here. So what we could do, okay. We can do this. Okay. Let's loop back around. Texture wrapper. We've done a tiny circle, but this is still okay. Turn texture wrapper. Right here, it is possible for us to create the sprite. There is no other information that we need than the texture wrapper to be set. So as soon as the JSON does this, we're okay. It is okay to do this duplication of the texture wrapper after, because we can duplicate the sprite, and then if we've set it and the sprite is not null, then we're okay. Because in the initial creation of the catalog sprite, we will set the texture wrapper, and then we'll call create sprite. Sprite is null. Because sprite is null, we will make our sprite, all of this goodness, and subsequently we'll have this. This is actually kind of useless at the time. We could make a custom conversion for this is texture wrapper to sprite and use that in here, but we're not gonna. Okay, so then when we initialize, we do not create the sprite. Instead, we just add the node. Then when we remove the sprite, if the sprite is present, the sprite has to be present during a remove sprite. We do not free the sprite. Let's see. We can say this is a just in case if we ever get rid of a sprite, a visual sprite, we do want to free it. I don't think we're going to. I'm going to put that there as a just in case for the time being. When we set the entity, that's when we know the position. So we initialize, which will set the node in entity. As part of set entity, we set the position of the node. Then we can add node to child to the node there. It's okay that we set the node's position before attaching the sprite. Move the entity, we clear the entity, we detach. When we remove the sprite, all we're doing to remove the sprite is detach the event and remove the sprite from the node. There are a couple of breakdowns we could have here. One of them would be happening right there. It didn't. Let's run that again. I want to see where in the stack we're destroying a visual sprite. This is the notation for a destructor, right? Okay, well, absolutely none of that worked. Because we're never creating it. Okay. Entity. Visual key. Catalog. We need that. Have all these gets for the various type. Get catalogable. Okay. as an entity visual. Initialize it with a node. We set up its removal. We add it as a child. We add the node as a child. Still no. Okay, let's go in here. Wait. Entity is our copy constructor. New. We have created an entity visual sprite now. Okay, it's not animating or anything like that yet. What else could be broken? We initialize it, we add the child. The base initialize, we set the node and we call set entity. We do not yet have a sprite. Do we? We definitely have the image. Sprite.play there. We've created it, but it's outside the tree. Oh, wow. You can see there's a blur behind it. Let's just pull that out. Wasn't our problem. Entity visual is gone at the end of this. It's a wrapper around an object that doesn't really exist. I mean, one of its children does, but we saw the destructor fire, and that's because it was here. Okay. Still no. Seeing this fire. Immediately seeing that fire. But where and why? Being created in one of the threads, I believe, but okay. So we're going to retrieve something from the catalog here when we get the key from the entity. 2copy contains a sprite. Should have all the relevant bits. So our current sprite, though, is null. It is the same sprite. It is the exact same sprite. Okay, so that's part of our problem. So we'll just do that. Setting the texture wrapper will trigger the sprite creation. Okay. Texture wrapper is no longer null. This sprite is a new sprite. 2copy sprite is a different sprite. Okay. We get to initialize. We have no node. We now have a node. We add a child to that node. And we tell the sprite to get going. We do get into here. Where we make the frames. Hey, that's weird. We are never getting to... We're never getting to here. Interesting. We create the visual, we add the visual to our collection, we initialize it, we set our event up. We should get this called a whole bunch of times. Visual sprite. It's a type of entity visual. This guy is chirping around in the background. What? Still food in the dish. Yeah. He's being very chatty. Alright. We have our get node. There's no node cache, so we're going to get a new node 2D. Up. Go in to our initialize. Our base initialize is going to go in, it's going to set the node, and then it's going to set the entity. We do the base set entity, which is just setting the entity. We're going to detach it if it's present. It's going to be present by the time we get to remove entity. Oh. Oh. Okay. Well, here's one problem already. So we initialize. Part of base initialize is to set the entity. Call set entity. By default, what set entity does is store the entity value. Then we're going to go further in here, and we're going to go to set entity in this one. First thing set entity does is rip it back out. Pull you off there. So when the entity is removed, we're going to remove entity here. Still not the source of the problem, but it's a starting point. Why is it stuck here? Get rid of the node. Add the node. So the sprite is just not animating is part of the problem. So let's run this over on the Godot side. Second here. Let's see what kind of errors we're getting. The Godot editor can register errors that or will show things that the C# side might not. All right, we've got debugger errors. Let's go. Hey there, Maki. Yeah, Delusive fired some gift subs, and it seems like you got tagged. It is a lot of exceptions, Maki. It is. Now you cannot be null, but where is it? On entity added, we're initializing the collision area. Why would the collision area ultimately call into texture wrapper? Base catalog 74. Okay, entity collision area 45. That's weird. Huh. Why does a collision area need a texture wrapper? Oh. Oh. For the time being, we gotta fix that. Found a problem. Oops. All right, let's run it for a bit here. Yeah, C# is actually a default part of Godot support. You have to use the one with the mono compiler built into it, but it runs pretty well. It runs pretty well. Letting it run for a bit to see, to make sure we don't have any sort of obvious leak behavior going on here. But it seems like we are recovering frames just as much as we are losing them. It might be drifting down. All right. Let's verify we don't have... Oh, well. That would be part of the problem. Grossly increased number of things. Over. No, we're not losing anything. We are seeing lower numbers crop back up. Let's make sure we don't have an oddity here. Entity limit before slowing down, we get into the like 1500, like the 1000 to 1500 territory, and we're gonna hit like 30 frames per second or so. The 800 area is still well above 60. Lower than that, and we can get, 1,000 physics frames, or 1,000 frames per second without really an issue. We've got it unbounded so that we can see what it's capable of. Physics frames are still ticking away at I think it's at 30 or 60 per second. Okay, in the visual sprite, need to make sure we remove sprite, we pull it off of the node, and we say oh no. We will get a different number here because we're not rendering the we're setting entity. No, setting entity, we should have node already. We initialize this, node equals node. So we get that. We set the entity and we do the base set entity. So by the time we get here, node should be set. This is going to be a case where we're reusing one. So we get a copy of the visual. We add it to our set. We initialize it. Remove the node. We put it into the cache. And we remove the visual from the set. This is already going to be a problem here. Okay, but the visual is purged. We have the node. Okay, so we don't need to worry about that. We don't need to null the node, because this visual is going to go away. Better way we can test this. Better way we can test this. We go over here. Run you. Should turn that debug off, but we'll get to it. Start that. We're going to do debugger. Orphan nodes. There we go. We're leaking nodes here. So if we make this real big, this will slow it down. This will get to the point where it slows down. So crossing the 1500 line, we start to drop real low. So we're sitting just under 2500. We're at 5 frames a second. We could probably get a little better if we did not have the extra circles rendering for the collision areas. But it wouldn't be like gameplay different. But at this point, most of that 2400 is bullets from the player. Hello, Donald. Welcome. Okay, if we look back over here, yeah, orphan nodes are scaling up. We're starting to lose frames per second. All right, where are we? Where are we losing these? So every time we're done with a entity visual, every time we throw away a copy, this sprite is getting orphaned. Immediately calling into this. But where? Because if I have a if sprite dot q free, well, maybe I'm wrong there. Let's go back into this side. We'll keep the monitor open. We're still leaking them. They're still leaking them quite steadily. Yeah, well, you know what? Let's look at the node cache and see here. We're going to get more nodes in the cache. Let's do a little CLI is less than services entity manager next entities. Plus node cache docs new node 2D. Just the auto suggestion on it moment by moment. So it just put in the code and said like, oh, you want a space here. I never use that. The suggestions that it puts in are wildly inconsistent with my code base sometimes. Sometimes it makes an appropriate guess, but as often as not, when it is not a is equal to new kind of operation, there's a good chance it will be nonsense that it suggests. It's weird. But don't worry, folks. AI will replace programmers, any time now. Let's go over here. Okay, so this makes sense. There should be this many orphan nodes. We should not exceed 7,500, though. And start. Go completely overboard. We put the snake pattern in because it's more likely to improve coverage. Right there. That shouldn't be possible. Shouldn't have been able to do that. We're creating a lot of them per second, but there's never more than that in the area. Okay. pull the child off of the tree, we put it in here, we remove the visual from the collection. So this visual is gone. There's no reference to it around anymore. It's distinctly possible that they live for quite a while. We're creating a bunch of them per second, but so this is 3 to the 4th per second. This is 3 to the 5th per second. This happens in a burst of 3, though. So 3 to the 4th, 1, 2, 3. They're going to live a while. They're going to do a lot of work. So yeah, there's never more than 2,500 in existence. Like, of everything together, there's never more than 2,500. The game doesn't allow there to be that many of them. So it's weird. Hey there, Lunar. It's weird that we were able to consume that many nodes at once in the debugger. Orphan nodes. The dating sim section where you're secretly juggling as many love interests as you can so they can provide passive bonuses to the meta progression side of things. So back in the PS1 era, I don't remember. Okay, that's wrong. That's wrong. That shouldn't have happened. That went at 76. It should never be able to do that. Back in the PS1 era, there was a... We're going to stop this here before it explodes again. There was a JRPG where the main character was the apprentice of a blacksmith. And so a big element of the game when you were adventuring was, to upgrade your equipment. But the mechanism for improving the quality of the weapons you made was the affection of arbitrary women, and each of them had a different buff that they would apply to weapons that they would, help you make. It was one of those, it wasn't it wasn't sexual what they showed, but it might as well have been. It was very odd. And the way the master blacksmith referred to it did not help that. Okay, there are circumstances where we are exceeding the cache. I'm sorry, where we're creating more orphans than the cache should allow to happen. It is possible that we're creating one and we're stuffing it to that. So what if we do node cache.e? Not equal null. then we'll pop one. Otherwise, we're going to get to this. This should not happen. This will be a test to see if it's our cache that's a problem. Hey there, Lore. Make many thing. Make more many thing. We have decidedly different behavior whether it's running through the Godot engine or not. This isn't too surprising because the C# side of things is generally better at the performance of it. Okay, we're going to pull some of these off. Pretty much, Lunar actual game. There are perhaps not surprising, but a surprising number of games where it turns out that it's like a semi-sleazy dating game under a thin veil of JRPG or similar. Sometimes more than semi-sleazy. There was one that had like singers that were similar. I think, was it Agorist Wars has a uncomfortable mechanic. Not because it's too surprising, it's the main character is always like a male, in like the in a royal lineage, and the successor is determined by who they marry, but the system of generating the new heir is referred to as the soul breed system, which is just a lot of ick when you think about it. And that is really, unfortunately, common as far as how it can show up. Not prolific, but I feel like too common by far. Okay, so it's not pitching a fit here. Let's go over to the Godot side. So this cache is not where the problem is happening. We are generating, let's remove those visible collision shapes. We are generating orphan nodes pretty swiftly on the Godot side. So let's remove that collision debug. That, and that, and that, and that, that. What does OBS say to that? OBS is on a separate computer that is protected from all of this nonsense. Oh. I hope that didn't cause an interruption. I hit the wrong button. Okay. There are spikes of orphan nodes that happen that are exceeding the threshold. Yeah, OBS is going to have fun rendering that, but to give you an idea, as far as the streaming computer, rendering me is 3 times more intensive than any other single thing happening on the streaming computer. Okay, so there are orphan nodes that are slipping through the cracks, but I think something about changing it to peak instead of checking count is saving us some pain here. Just for visual flair, let's switch to this one. Whee! Get these neat little corkscrew patterns. Let's put that one there. So the reason that I shoot for super high frames per second and that I want to be able to have like 1500 things on the screen is I want the game to still run when we're doing this. The player should not frequently get to this point. This is not quite, but it's on the verge of what I call a calamity case, and that is the system is being pushed to its limits as far as performance or functionality. But we're still getting over 10 frames a second here. I say that just as it plummets down below, but we're still getting 5 to 15 frames a second. Which, for this much going on the screen at once, is, I think, okay. Would I like better than this? Yes, and I'm wondering if some of the things that I'll be doing next could factor into that. For one, I want to change these explosions to a particle instead of the sprite as they are, and see if that improves things any. Right now, they're a very hacky animated sprite. And they should not be that way. But we'll see. We'll see how that do. We're going to take a quick break here. I'll be right back. I'm going to keep it running just to see if we get some sort of error down the road. But be right back. You know, I haven't tracked GPU performance of this actually, Delusive. Let me check that. We'll put the cameras on for a moment. Put the game at bonkers mode here in the background. pull up our system monitor. GPU and CPU aren't taxed much by this at all. Actually, that's weird. He said. Just checking some stuff here. Did I find a way to break it? Running at kind of max strain there. Yeah, max CPU utilization while the game is running, and GPU 20 to 30% tops. That's with it running in Visual Studio, with Godot running, with performance monitor running, all of the things that are going to actually choke the system going. So that was also with 4,700 entities active at 2 to 3 frames per second. Yeah, I do suspect that somebody would be like, "Oh man, why is it taking so much?" I do want to make more use of shaders and particles to see if we can get more use out of the GPU to reduce CPU load. But we'll see. We'll see. But also, if I stop processing all of the movement, and I just have the object, so no movement, no collision is happening right now. And I just have the object sit here. We're at a 80 to 100 frames a second at 4,700 entities. So if everything is holding still, the rendering is next to nothing comparatively. But with this many objects moving, like handling all of the collision and similar, then things get more complicated. So, for example, right now, these choose a random direction. They choose a random enemy at the start, and they draw a straight line towards that enemy, and they move on that straight line. Yeah. Running on weaker systems, being able to run on weaker systems will be an attractive option. And that's why we do want to keep the number of entities lower. If for no other reason, there's not really a big win to having more of them. Only so many things fit on the screen. I think it's like we could flood the screen with like 700 enemies at once. If that is the circumstance, if there's 700 enemies on the screen at once, you are about to lose. They will be touching the player during that. During that time, that means you also aren't firing enough bullets to slow them down, which means those bullets are going to be getting eaten, either by the enemies or they're going off the screen. So that is going to put us in the under 1,000 territory. But yeah, we have 3 to the 5th projectiles per second being generated, and each one of those has a kind of complicated inward spiral behavior on its path, which is going to create kind of a loop-de-loop as it moves out. And while it's doing that, it is constantly rotated left or right. So it's not cheap for them to move. It's cheap for the enemies to move. The enemies move directly towards the player. And they only collide with the player, so their collision math is easy. The bullets can collide with enemies, so their collision is going to be a little more complicated. There will be way more enemies to collide with, so the calculation is pricier. Okay. I think. All right, let's get a commit in there. All right, so we have sprite visuals in. The advantage now is that the whole concept of entity visuals is now in the game, which means we can now make a different type of entity visual. We still do have to revisit this. Real quickly, let me write this down. I must not forget that is an issue. I think in the entity we have to define a collision shape for them. That'll be a whole other ball of wax. We will inevitably get to that, but I don't want to lose it, so. Is infrastructure. Okay, particles. You can have particles living on the GPU or the CPU. We're probably going to start with GPU, see if the performance is okay. We can always switch them over as needed. There is a variation. GPU particles do have GPU-specific features, but if the load is too low or the GPU is too weak, you can either waste time with the handoff to the GPU, or you can have the GPU becoming a bottleneck. I would assume that if your CPU is mighty enough that your GPU is a bottleneck, that means that you have grafted a potato into your rig. Your rig is not a potato, it contains a potato. Within reason. Very few particle emitters would likely fall into the category of wasting time, you know? What you doing, Sky, huh? You come to be a nuisance. Yeah. Yeah. Okie dokie. So we're going to need a new type of entity visual. Where did we put that? It's not part of the catalog. It's not part of collisions. It is... should be part of the entity somewhere. No, wait, it's part of rendering. Here. Loading. Actually, so, Lunar, on topic of a slider for max entities, I've actually seen that in a Bullet Heaven style game. Rogue Genesia actually has toggles for that kind of thing, where you can limit how many things can be generated per unit time. That sort of setting, which will impact the game drastically, but can also aid performance at extreme edge cases. And boy, that game could reach edge cases. Yep, I know, game. I know. One of these times I'll have to read that and understand what it means. That is a game that desperately wants you to break it. Where you get to that, like, 1 or less frames per second and moving at all becomes a difficult prospect. And you don't move in terms of, screen space or pixels per second. You're moving entire screens per second because of how much speed you have paired with how few frames you're going to get. You just get tick, you're across the room. Tick, you're across the room. Supposedly King's Quest 1 speedrunning is like that. Potentially some of the later King's Quest 2. Where at the lower speed settings of the game, the first 2, it just sets up a number of frames, like ticks per frame that you get, kind of thing, which keeps it reasonable. The game is very slow as far as how fast things can move, but that's still visually reasonable. But if you set the game to full speed, if you essentially put it on turbo mode, it removes that boundary. So it's as many ticks as it can process. And the King's Quest games are old DOS games. So the amount of processing that they can handle per unit time is phenomenal. So, and the difficulty is that movement is a matter in those games is you press the movement button and until, oh, come on, Molly. So Molly wanted to walk down from the bridge. And so she doesn't want to step on Sherbet, who is right here. So instead, she crawls over my soundboard and heads towards my lap, where Sky is. And she proceeds to try to jam her feet onto my keyboard. I don't know if you could hear the Windows sounds. I think I have desktop sound off, so you probably couldn't. But rapid, like, I can't do that Windows bleeps, followed by her planting her other paw in Sky's face, which disturbed him greatly. So I had to extricate her from the situation. Which extends entity visual. Okay, this will be a very similar animal to entity visual sprite. So we have protected animated sprite 2D. Let's go in. What is it called? It is a GPU particle 2D. Okay, so similar song and dance is it's going to be created and go away. So Lunar's question is, does the player move or does the world move? So if the world moves around the player, that still creates the question of, is the player permanently at 0-0? If the player is always at 0-0, but when the player moves, essentially the world slides around them, then the math for moving the player becomes iterating over everything in the world and moving it. Which isn't out of the question, but currently moving the player is change the position of the player. It is one movement, so it is one collision area that changes, and one visual element that changes. I don't know what particular sorcery they're doing in the background of Outer Wilds to make everything else move. But I feel like having all of their positions kind of snap after each other move is, I don't know how I would make that work better or even as good under our current model. Has to be something else, you know? Beverage. All right. Hey there, cat girl. Welcome, welcome. We're working on our game. We're actually getting to the thing that I wanted to get to earlier today, and that's adding particle emitters as a possible visual format for our rendering. Because right now, loading, everything is going to be an animated sprite. So in particular things like that explosion, I'd rather it be a particle so it can kind of do its thing and go away. Hello, Coco. I think Coco, but you've got... Is it Cyrillic? Is that... I can't remember the terminology for the difference in like Russian alphabet, that kind of thing. But it looks like Coco, so I'm going to say Coco at the beginning. But hello. So right now they're all animated sprites. We want to have other things. Twofold, because some of them are not going to just be a ball in space. Some of them are going to be temporary, but additionally I want to be able to have things like a laser beam. And a laser beam isn't really going to work as just an animated sprite easily. A particle would be much easier to do for that, where I could essentially say emit a particle along this line, whether it is backwards or forwards. I could say draw it from its point to its current position to its origin, or from its origin to its current position. Fire particles. Kind of thing. Gives us some flexibility. So we gonna work on that. So I create a particle. What do we do here? Yeah, but that's the thing, you just need enough of them. Or I could have one that takes an image and just smears it across the screen, or across its canvas space. I don't know how Noida did its beams, but it was something along those lines. Is a Noida, like, direct line, like beam weapon, you would actually make a short sprite for it that was, like, left to right aligned, and it would sort of stretch it across. Okay, so we need a particle process material that we are going to attach to it. We can attach textures to that. Song and dance there. And then we can do various elements here of how long they live, all of that. We'll have to see. We'll have to see what we can accomplish with particles, Lunar, and determine how much we need to work with them. All right, so let's just copy most of the guts over from the sprite, and we will go from there. I'm copying over the sprite not because we will actually be using it in the same way, but because the general flow is going to be very similar. Don't have that. Let's see, move particle. Unbind, and we are going to remove the particle from the node. So this is still the same kind of concept. It won't have one of these. And much of this. So we're going to generate the particle here. We initialize, we add the particle here. Because we're given the node, and we're given the entity. Texture wrapper will actually still be useful. We go to the definition there. We are going to create a particle. This might still be relevant. Play once. We'll keep that. This might still actually be relevant. The entity animation includes things like you're holding still, you're moving, and we might have different particle effect patterns associated with that. But we'll see. Most of this isn't the case, but for now we're going to say move the node. Okay, so we have the basics here. Now we need to create the particle. What is it called? It is a particle process material. That process material, in theory, this might get us all that we need here. Alistor, welcome, welcome. Okay. So we're going to go in and we're going to make a new visual. Welcome back. Nope. Visual, visual particle. Still has a play once. This should let us mess around with it a little bit. I still need to tweak the file rating so that it can handle encountering a file that's open, that it can handle not finishing a load. Ah. Do. Ah. Oopsie doopsie. I'm a nanotype. I am a robotic cat. Though I understand people. I understand the assertion of perhaps rat, perhaps fox. I have now heard both of those. But out the cat. Okay, we need to be able to create the particle. In theory, at the moment, we don't even need a texture wrapper for it. So we're going to move create particle down here, but we will have to... There are going to be other variables we use. Texture wrapper is actually going to be one of them. We can always pull it back over as needed. Oh, look at those two. They're all snuggly. Oh, there it goes. You probably can't see it at all. Here, let's make a bunch of them and see if you can spot it. Can you see the little white sparkles? Itty bitty white sparkles. Okay, well, our particle engine is already in place then. Hooray, we're definitely not done yet. Put that back in. Yeah, there we go. Okay. Okay, this doesn't need to be a full get set that way. It just needs to be like that. Just so. Oh, we'll leave that as is for now. It's an imperfect checkerboard because this spot right here, this region here, so there's a tiny red dot that exists at 0, 0. Let me clear this. There's a tiny red dot here. Everything down and right from that dot, so including the square the player is standing in, everything down and right from that is what's called the fixed map. Everything everything around the fixed map is the repeating map. I don't know if that's going to be how we do it in the end of the game, but effectively the fixed map is defined. It is hand built. The repeating map is as well, but it just goes on forever. So once you're outside of the fixed map, it's an eternally repeating pattern. I may just make it so that there's like a world border around the edge and you can't leave it. But I don't know that that will really be necessary. We'll see. Okay, so one quandary here is that if a texture wrapper is present, we need to incorporate that. That would become part of... Where are you hiding? I believe our process material. No, it would actually be the texture of the particle. Yes. Okay. So if we wanted to set a texture, you would set the texture. You can use an animation flipbook, which is individual pieces here. So, canvas item material, H-frames. So what we don't want is to have in the canvas material linear playback. What this implies is that this should still work for us here. Let me double check. Data, textures, bullet explosion. Okay, that should still work. So if we have a texture, we want to set that as part of the particle. So when we create the particle from a copy, we'll use the texture. We are going to have to create the particle when we initially instantiate it, though. This was previously accomplished in the getter setter for the texture wrapper. Which we could still do. Because we don't want to completely remake the particle every time. The one in the catalog has pretty much everything we need. So we can copy the texture wrapper. When we initialize it, or let's see, yeah, whenever we set the texture, either when we're copying it or when it's loaded in, that's when we're going to create the sprite, and the sprite is created once. Ugh. Okay. And we're still gonna need a lot of this, actually. A lot of this same logic. So the texture changing can happen at any point, but the particle needs to exist for that to work. Okay. Okay. We could do this with the sprite, too. But for now... So with the sprite, the texture is critical. If the texture isn't there, we can't really finish making the sprite. The texture for the particle can be set after. It just means the particle doesn't look right until it is. Okay, so we have particle here, and we are going to have protected GPU particle 2D particle. That has a get set. Don't really ever set particle. You mess with this guy. But we'll still do it. So get it, we are going to return particle. So if particle is not null, we're going to return particle. Otherwise, for now, we're going to put null there. We're going to create particle. Let's do that beforehand. If cleaner. So if we don't have a particle when we go to get particle, we create it. This means we have to reference it as its property. We do not reference its internal. And we can't do a Godot duplicate anyhow, so okie And when we're copying, we can copy the texture wrapper as well. Services.catalog.copy. Copy the wrapper. Visual.texture wrapper. And as a texture wrapper. Okay. So then when we set the texture wrapper, we are going to want to go in and mess with the particle. So here's our process material. We've got that. There will be variables associated with the process material. Most of the variables on this are going to result in the particle being created if it's not already there. A lot of it is going to trigger create particle. It do be like that sometimes, Alistair. The nature of tall form chat is that people swipe through very quickly. Okay, so then... This is sloppy. Don't like it. We're just going to have to call create particle in a lot of places. No. No, actually. No, we're okay. We're okay. System. I'm glad you like it. DevWorks going okay. We're introducing particle-based visuals. The crystal in the chest. Here, let me show you. Zoom and enhance. As my heart. It is the Nano core. Oh, once again for new folks. There you go. Okay, so if we set the particle texture, that happens here. It's protected. Texture wrapper. Texture wrapper. Underscore. Wrapper. Value set. Particle texture. Texture. So by doing particle here, it is going to result in the creation of the particle if it's not there. Okay. We need revisit that. There's all kinds of neat stuff we can do there. Set the texture. Let's just do that at the moment. Okay, so we need to set our texture wrapper property. It would just be that. Does this break it? Let's find out. It does. Oh, it doesn't. Close that. Reload that. Okay. So it's not what it's supposed to look like, but it is emitting the explosion particle, or the explosion sprite, as a particle. So now we'll have the explosion particle emit explosions, and, you know, double up on the explosions. And put OBS, there it is. Okay. Alright, now we need it to be an animation, which we can pull from the sprite here. So this little bit here, it's not quite the same terminology, but we're just going to graft it over. Rows. So then particle dot is it? So in the animation flipbook, okay. Dot material is equal to new canvas item material. Particle animation, and then we have H frames and V frames. H frames, horizontal frames should be columns. Rows. So then particle dot material equal to material. Anything else we have to do? All right, let's try that. It's gonna totally work first time. Okay, not quite. It's only showing the first frame. That to get it out of the way. Here, you can see just the little blue bits there. Needs to be part of the animation here. As might be apparent, this is a real learn-along scenario. Okay, so I think this is the canvas item material. So it's animation. Animation dot speed. Oh, it's a boolean there. Well, thank you, Alistair. Is that part of the particle? Speed scale. So what we're doing here is we're programmatically creating this. The article that I'm showing, this is the inspector panel of the Godot engine itself. I don't want to deal with that. I want to do it all in code. It is generally cleaner this way. Article flipbook animation is only effective if the canvas item material. Okay, so something in particle has got to be what we're looking for. Circle, no. Are you hiding? Not part of this. Side of material. Particle animation, yes. Particle 2D has an amount and a ratio. Part of the particle process material? We're finding the pieces here. There we go. Process material. Okay, so this is where that gets real messy. Ugh. Right there. All later. Process material dot speed. Process material. All of this stuff gets set up during this. Okay, so we're gonna keep these around just in case I need to reference them, because if I need to double back to it, I don't want to rebuild these things. Speed min and max is equal to 1. Hey, Henry. Welcome. Default movement behavior is going to be number of images total divided by its lifetime. So there are how many images in the explosion? There are 6. So we need 6 frames per second. So its lifetime is going to be 1. Let's get you over here. Create the particle initially. This will need to be calculated. We will need to figure out how to do that. It's not quite right, but, you know. We're getting there. That doesn't seem right. We'll need to set its scale. Scale. We make the particle. So the time on it is off. I'll have to check how I'm doing the sprite animations. says it should be 6 frames per second, but that's way faster. It's playing through the whole animation multiple times. This implies that since we have 6 images with a lifespan of 1... Oh. Wait. It says a lifetime of 1. And its min speed is 1. We'll have to set it up so the node render actually cleans itself out. That's a long-term memory leak there. Animation speed doesn't tell me that. Animation speed of 1 means that the particle will make a full 0 to 1 offset cycle during the lifetime. 2 means 2 cycles. For science. I'm just trying to figure out how to interpret this number. Okay, that does make it faster. Full animation in a second. Why is that playing out so quickly then? Let's set its lifetime. Let's verify how many frames we have. Should be a 6th one right there. We are getting through to that, and it should be disappearing. We don't really need the disappear anymore, but is what it is at the moment. Let's look at the sprite. So relative duration of the frame. get frame duration. Duration of 2 is displayed twice as long as the frame with a duration of 1. So our fractions there. But if we make the particles live longer, weird. Trying to figure out how we're doing this here. The animation and the custom speed. We are explicitly saying that the speed is 1, and each frame is 1, so that will be 6 frames that get added. How do we make it so that this plays out properly here? So we trying to figure out the relation of these variables because they don't seem to line up with what we're doing here. The scale is not right either. And be trying to get it to line up properly here. Okay, there's the right scale on the particles. They're going way too fast. Let's just go into, seizure warning mode here, folks. Because it doesn't seem like this is the correct value. I believe this was way too fast. Hey, Garrett. I believe this was way too fast. Yeah, it's twice what it should be. Based on what it said, this should be a full cycle in 1 second. But maybe I'm misreading that. A couple things here. And okay. All right, what's that say now? Animation will reach its last image in the sequence just as the particle's lifespan ends. Its lifespan is 1, a full second. Oh, you actually heard Sky. Oh, wow. Normally that is filtered. Oh, yeah, it's coming through. Isn't that right? Yeah. Yeah, normally it would be filtered. But I think my noise filter is broken right now, and I can't really correct it without blowing up my sound briefly. And I don't feel like doing that just yet. The reason I have it is that normally other noises might not be filtered. And that could be annoying. Though perhaps Sky crying into the microphone is considered enough of a voice that it still lets it through. Yeah, it's the filters aren't active. You shouldn't have been able, the clap shouldn't have come through. I know. Yeah. You have food, and you have water, but he doesn't have enough chin scratches. It's not an offset thing, it's a speed thing. Yeah, the animation, like, okay, let's... What about lifespan? What is lifespan referring to in this case? Maybe I'm using that wrong. Amount times amount ratio divided by... 1. Yeah, Molly is snuggled up against Sherbet right now. That's about right. That's about right. Okay. It's if you have multiple of them being emitted at once, the animation is kind of stacked with it. So you have to account for the amount that are emitted too. That will get fiddly fast. Well, we'll see. Burn that bridge when we cross it. Okay. So now we need to change this to be the explosive one. So we've created the particle. What events do we have? With a process material? Script. Not part of the process material. No. So here, let me show you a couple of them here. One way to look at it is that effectively every movement is either an accelerator or an alteration to it. So zigzag and curve are alterations. They rotate the direction that it's moving. So these don't change the speed. What these end up doing is that they move the projectile. So this is track an enemy, this is random direction, this is spiral in, spiral out. Each of these is a movement pattern that applies a force to the projectile. So if you look, the yarn ball is moving, well, the explosions are moving at a particular pace out from... I kind of like the burst when it's moving that quickly. Anyway, they're moving out at a steady pace. But if I add spiral in here, well, you can't really see them here. Let me get that particle off of it for now. Visual bullet yarn ball. It's the file. Restart. You're close. You're close. So for example, when I do this, when I add the spread, the original bullet is unaffected, but it's going to create 2 more bullets, and each of those is rotated 45 degrees off of center. They're inside their code, they're kind of moving in the same direction. As far as they're concerned, the direction that they were told to move has just been rotated. So these said, like, move directly to the left at that enemy directly to the left. But when they were created, the rotation was applied, so that directly to the left turned into, butt down 45 degrees. Then if I take spiral out here, if I put spiral out on it, what spiral out does is a lot of math, but it determines, given a radius that it is expecting to be at and a speed that it's expecting to move at, what should it curve at? Like, what angle and movement should it apply in order to continue along the path properly? So that technically speeds it up. Same with spiral in, it is moving faster. The actual velocity along its path has now increased. Whereas with the curve, this doesn't move any. Actually, it's moving slower along its path when you curve it. If you draw a straight line along its path, the curve slows it down because its path is now longer, the actual path that it moves along. But its linear speed, like along that new path, has not changed. If I add rotation like this, the speed along the path, as far as its total speed of movement, has increased because the ball has a base speed, and then this applies an additional movement to it. So these four right here push on the projectile or the object. These rotate it. Yeah, they effectively apply an offset. They move it. These change how that movement is done. These alter the direction of it, but they do not apply their own movement. Okie dokie. So now we could have a lifespan set to the explosion to be essentially it's immediately dead. It immediately goes away. So that it can come into existence and it can do damage, and then it goes away. Then we attach the particle effect to it. We do need to, for the particles, we will need to add like duration of the animation, number of particles, all that kind of stuff, because this plays into what it looks like. So I could have a single image, or I could have a variety of them that will emit, but if there's an animation to them, I need to account for that when I need to account for how many there are, that kind of thing. Look at our animation here. It's weird that I have to set the amount to 1. What if we do 2 here? What does that do? Well, nothing, because I don't have those visible. let's get that bullet visual in here. So explosion is now going to be a particle. It's essentially has become particle test here. I'm going to get rid of that and make sure it's still running. Nothing should be referencing it. Close the file. Still need to fix that. Gotta put it on the list. Put that there. How about... I think we had to set the amount of them. Okay, let's put 3 there and see what happens. There. Okay, and if we set back to 1, that. Yeah. Okay. Let's get a interim in here. That is technically possible. Pausing the animations. We'll see if we get around to doing that. Right now, the animations don't have any like functional effect. Aside from the explosions. The explosions now would fire and go away while paused. So we'll have to see what we need to do to deal with that. Put those there. Now we need to go into our data file. And we've got our... It's probably like a timer effect, right? I don't think they do. If I recall, they don't. Okay, we're going to remove that persistence from it. It has a 0 lifespan. And now we go up into our bullet for it, and we want to make sure that the damage happens before the lifespan. Well, we're going to see if this works. Let's also check our collision and make sure, because we don't care on collision that the source is alive. We only care about the target being alive. Close the file. Okay, the particle is never happening. It's immediately being removed. All right, we still have to tweak that. What we do? Because as soon as the lifespan ends, it's trying to get rid of the creature. And, you know, the explosion is a creature. So we go to timers, lifespan timer. We get time passed, and we're eating the lifespan message with that. That's okay. The time passed isn't the problem. Gonna remove that. We don't want persist to do anything anymore. We're calling to remove the entity here. Entity manager, it's in base entity manager. And we're looking for remove entity. Remove entity. We add it to that. We get all the way up into our update. We find it, we get rid of it. We remove it from the collection. Doesn't seem right. Health. Change. I've lost track of where we're actually triggering the entity remove properly here. So we're calling into this. We're adding it to the entity remove collection. During an update, we have entities to remove. Okay, we call entity remove here, which will trigger the result. Entity remove does not happen until the top of the next update. The top of the next update is when the collision events will happen. So if we look at our game, child, here we go. So we update the entity manager and then we check for collisions. The entity manager updating will bring things into existence. That's when they're actually added, and then the first behavior happens on them. Hey, Pretender. Welcome. If we check collisions before entities come into existence, this might... Don't know if it will work correctly, but... Animation is still not playing out. You will notice that the blobs are being knocked out before the bullets hit them, and that's because the collision box of them is currently too big. Okay, I think that's working. Now the question is, what if... Pretender, yes, this is my first game. So we are taking much longer with it than would be expected because I'm making more than like a, first game tutorial game. I'm being ambitious. Because checking for collisions is checking for the last world state, and we're going to send those messages out, and they'll react to them accordingly. Thank you, Pretender. I like how it turned out. It is more is kind of everything I asked for. Very well done. Now, so the explosion triggers. The explosion is created. It comes into existence. Technically as part of player state. So it exists here. It's created, it gets its lifespan message. I asked to be a robotic catboy, yes. But in a great deal of detail. Great deal of detail. So when I pause, the actual lifespan of something is controlled here. The only time that the world moves forward, aside from the way that the sprite animations play, everything actually stops when the game is paused. So this step isn't happening because we're paused. So this creates the item. No collisions happen yet because we haven't had a full physics step yet. Things move, so the entity ceases to be at the top of the next one, which will remove the visual almost immediately. If we move the persistence flag, don't worry about not being aware of what's going on with the code. I do try to talk through the thought process of what's happening. We're pretty far into the weeds here, but I'm talking through the process of why we're not seeing the explosions happen right now. So it comes into existence. It hasn't had even a fraction of a second to exist yet. It's been like 0.01 seconds or something like that. It is a bullet heaven style game, so kind of like Vampire Survivors. The actual plot of the game is going to be tied to the character lore. I'm keeping vague about it because there are going to be elements about it that I want to be sort of players uncover as they play. I don't expect it'll take a long time for people to find them, but there will be little nuances of stuff. Yeah, Lunar is correct there, Pretender. There are times when somebody mentioning something can kind of jostle the ideas around properly so that we get a new path. Or it's just a cool idea. But again, don't worry about not knowing about coding or about Godot engine or anything like that. If you want to just listen along, listen along. If you have a question, ask a question. The primary way to learn this kind of stuff is exposure and trying it out, and this will count as a lot of exposure to it. Okay, so after that first moment, the collisions happen. It should be registering them. We should have a mass harm collision happening. But collision mass harm is entirely just, it has no limits on how much it does. So it has a collision count or a collision limit that is kind of, I think it's set to, yeah. It's set to 0. It will just rack up collisions. So we want to see else that. I'm just going to break on that. I want to see if the explosion collision is happening. And the explosion collision is the only one with that currently does a mass harm. It does a hit as many things as you want. Okay. We are getting the hit, which means we did send the message. It can hit things. Hey there, Maddie. Welcome, welcome. Okay, and they are being removed. The explosion does exist. So now, we need a way to make the particle go away when it's done. Well, thank you for the compliment, Maddie, and thank you for swinging through. Okay, we need the particle to go away when it's done, not when the entity goes away. So we need to see if there's an event somewhere in here that we can latch onto to say when it is finished. Finished. Okay, so we create the particle and we are going to say we are going to add a new property here. You are JSON ignore, by the way. I'm going to leave that around, but particle finished. We remove the particle. And that's pretty much how it goes. Alt has mentioned the as far as coding, it's a lot of it is looking stuff up. There is a propensity for folks to assert that things like training are incredibly necessary, and that you should memorize stuff, that you should never have to look it up. But we live in the internet age, and pretty much the entirety of the knowledge base of not only coding languages but programmers exists for you to tap into. Go forth and learn. Okay, so if when the entity is removed, if not persist, I don't know that I want this to be called persist, but it's effectively survive entity. So if we're not persisting, then the entity's removal will remove us. If we are persisting, then when the particle is done, we go away. This will once again totally work first time. Bullet explosion, visual, and it's going to be persist. This is true. And this is a string value. Okay. In theory, we should see the explosion play out now. But we didn't. Oh, up. Persist is equal to visual dot persist. You're never messing with the thing that directly came from JSON. You're messing with a copy of it, and that copying has to happen. If you don't copy it, it doesn't get copied. Okay, I am seeing some overlap there. And I can see it repeating. I like that one. I'm really fond of all the emojis. But that's a fun one, little box of cats. Shameless plug, but the membership veterancy changes make it so that your profile icon goes from a catbot. It starts as a catbot, and it increasingly accumulates cats draped on it with veterancy. Okay. Okay, the particles are not going away with this. So we're triggering removal in particle finished. This should make the particle go away. Tassie was very active in Twitch chat as far as sub gifs. As well as like bits. Our initial era of streaming had a period of much gifting, and we always appreciate that, no matter how long it has been. The gifts were given and the gifts were appreciated. Okay, but they're lingering. Several years ago. I don't have the exact date on hand. I have it written down somewhere. It's been a bit. When we create the particle, by this time we'll have persist. What if Hey, Henry. Okay, so the explosions are going away. The explosion is very small right now, so... So it's not able to hit much. We're going to say this further indicates that persist isn't the best word for it. What we really mean here is to let the particles fully play out. Yes, there is... If you look back at my old VODs, shameless plug, look back at my old VODs, you can see that a lot of them are into the shorts, relate to a game called Noida. And that is a non-trivial part of the inspiration for what we're doing, is the game Noida. Now, the camera array is completely flaking out now. Really got to get those changed over. So if we persist when particle finished, we go through this. This is play through the particle once. So we're going to change that name at some point to... Particles don't really care about entity animations, but they might. There might be some change to that. Yep. Vampire survivors and the like. Okay, then the next thing we need to consider... We're going to need to consider putting hitboxes as a separate thing. So I'll need to create a bit of logic to attach to an entity that tells you how big of a hitbox to make, such that when we get to our collision manager, well, ultimately when we create an entity collision area, this stuff is determined by what the entity makes, which is going to make the entity collision area a catalogable, where we will define how big the collision box is, that kind of stuff. And it will be given an entity to react to. So, kind of what we did already. All right, check a couple of things here real quick. Okay, we're gonna go a little bit further, but we do have to take a quick break. I will be back in a moment. filter active again. Step on that. Okay, let's see. Let's check our current state here. We are going to change the naming on that. So check before we update the entities again. No, we made it so that the source of an event can go inactive while it's still being a valid event for collisions. That way, if, say, like, a bullet strikes something and the bullet is removed or is flagged as inactive during that process, it would still count as a valid collision on the subsequent check. In particular, this affects timers. If a lifespan ends during the last step, its collision is still valid. So in the fraction of a second after the lifespan ticked, we count it as having been there. It's not perfect. Ideally, all of the events would be cleaned up, but because the collisions only get calculated at the end of the physics step, or at the beginning, but it's once. So during the physics step, we do not have access to fresh collisions based on things that we do during that physics tick. We need to get the next tick, so it will always be one after. So the explosion needs to survive all the way to the start of the next tick. So we need to check collisions first, that kind of thing. Okay, so in the visual particle, we're going to change the name. We're actually going to call this play once. It's essentially going to be play to completion here. Let's make it loop all over the place. Should be getting explosions, though. Welcome back, Levi. We are not. All right, we broke something about this. Play once that way, and we create the particle. Play once false. That's not right. Once it's coming through false. When it was read in, there are no particles that should have that, or that shouldn't have that equal to true. When we initially create it, it's false, but put it in the wrong spot. That's correct. Visual bullet explosion. Texture wrapper. Oh. Womp womp. Already had it over there. All right, there we go. Okay, but now they're not going away. Odd. Okay, that event is never firing. But it should, because this is getting set to true. Set those. We set its canvas item. One shot is still true. But if finished is never firing, that means that there's some intrinsic breakdown in what's happening here. Because we're setting all the bits. Like, that's ready to go. That's ready to go. This should now be particle should run through one animation now and hit this. But it doesn't, so we're getting stacking, looping animations here. Once. There we go. Nope. See, for one, they're linked. They're. Oh, what changed? What changed? Let's see if that's getting hit here, the remove particle part. It is not. Why did that stop working? So we're not even going in there. Just for giggles. I don't think this is the scenario that's plaguing us, but we have to check. Nope. refactoring. Weird. The tricky element of this is it was working. Oh, what? All right, which was it? So I don't think it's this one. Why would that matter? Play once is true. That's true. Okay. Play once is true. Particle one shot is now true. Huh? What was going on here? This implies that play once is not true when this is happening. We should reach this. Yeah. This is true. So this is true. So that gets set. But it's not. What is wrong? No, it's... It doesn't work when we're setting it to... idea. CPU particles are precompiled. CPU particles are precompiled. Okay. Let's do a test here. Describe my incredulity in a moment. It's not working at all. I mean, we could extend this and have that it's a one-shot particle, and that we set the values on it to force it to restart, or not. Like now it's not running at all, which is again very strange. I might have to pre-build these, because I wonder if that's part of its problem. It's one shot true. About that false, and we immediately trigger removal. That gets rid of it. So this is play once is false. Play once is true. Then we should get here. But we aren't. Oh, no. we should get here. Well, we still aren't, but it looks like we are. This because it's GPU. I have to believe it's because it's GPU. I think there might be some sort of sorcery going on here. That particular elements of its behavior have to be set one and done. Like, once we have created this, this is an absolute kind of thing. And as far as this particle is concerned, this is built, and this is forever. We are going to have to look at that closely, because this is a strange behavior surface for sure. The fact that it's a GPU particle does cause that to make some sense. It's just figuring out the exact behaviors is going to be tricky. Bouncing isn't behaving quite correctly, but we'll get there. We're getting some of them that are behaving like it's a pierce, as if the, Okay, and explosions are hitting things. Okay. Alright. I think that's gonna about do it for the night, folks. We do need to figure out a couple of other things heading in here, but that does make the next target getting the collisions wired up to be separate things, so that we can have that collision area report it can send messages to and track a particular entity, but its definition is elsewhere. So that we can have it where an entity has a particular sort of collision area that it makes. Probably set up a similar way that there's a text key to say, this one. A lot of them are probably going to be able to be standardized, like, this is a 16 radius circle, this is a 32 radius circle, kind of thing. And you pair them appropriately. I might be able to put the values in some location that will make it easier, but we'll see. We'll see, because I don't necessarily want entity to be the only thing that can have a collision zone created. Maybe there will be others. But again, we'll see. In any event, I hope everybody had a good time watching with us tonight. If you did and you'd like to see more, remember to like, follow, subscribe, hit all those buttons. does help the channel grow. Lets me know what kind of things you folks like. If you'd like to consider supporting the channel financially, you can do so through memberships, subscriptions, all of that kind of stuff, platform-specific stuff. You can also do it through Patreon and Coffee, and things like what's listed in my Throne account. No, not... Yes, that, but also all of the things listed in my Linktree. Words and things. Linktree can be found in the video description and in my bio. And with that said, I hope the rest of your day is good, and I'll see you next time.